We are going to be talking about probability. It's still a continuation from the section that we were in, and you guys pretty much have been dealing with probability already from when you were, I think what third grade is when you first learned about probability. But it's going to be something that's very familiar to you. So you guys are going to be able to find the probability of an event occurring. Something that may be new to you is you being able to find the complement of an event and even potentially compound probability. But those are going to be the three things we talk about today, and it is involving two foldables. So in the first foldable that says Introduction to Probability, let's talk about what probability is. Probability is the probability of an event happening is always written in this form, P parentheses event. Now, do realize that the word event is going to change depending on what the event is. So, for example, if you have a die and you roll it and you want to see what's the probability of you getting a 4, then P parentheses event would be P parentheses rolling a 4, like that. And what probability of an event it measures is the likelihood that an event occurs. So it is possible for you to have a probability that's impossible, which means there is a 0% chance of it happening. Or you can have a probability that is certain, which there is 100% likely to happen. This can be converted into a decimal, but a 0% as a decimal is just 0, and 100% as a decimal is actually just 1. From there, it can be broken down into quarters. As likely as not would be halfway through that, so that would be 1/2 or 50%. Unlikely would be half of that, which would be a quarter or 25%, and likely would be 3/4 or 75%. Okay, and do realize that when it says probability, it is the decimal version of the number, not the percentage. Percentage is when you multiply by 100. Right? Probability is measured on a scale of 0 to 1, as you can see, and it can also be expressed, like I said, as a fraction, 1/2, 1/4, 3/4, a decimal, so that would be examples like 0.25, 0.50, 0.75, or as a percent, which could be like 25%, 50%, or 100%, for example. Okay, so these are all different ways that you can represent probability. So let's talk about the likelihood of some of these events happening, okay? So we're going to describe the likelihood of, or the probability of each event. You roll a six-sided number cube and it lands on the number 1 or greater. Well, if you think about a die that has 6 sides, they're labeled 1 through 6. So no matter what, this is certain that you're going to get a number that's either a 1 or greater. It's 100%. We're taking out those examples where it could potentially lie on a corner or on the side of the die. We're taking out all those hypothetical type of situations. A bag contains 3 red and 5 blue marbles. You reach into the bag and you pull out a purple marble. Well, the probability of this happening is impossible. Why is this impossible? Well, because you have a bag that only has red and blue marbles. There are no purple marbles in there. So the probability of you pulling a purple marble is 0%. A spinner is divided into 6 equal sections labeled 1 through 6. You spin it and it lands on an even number. Well, if a spinner has sections 1 through 6 labeled, that means that out of the spinner you have sides 1, 2, 3, 4, 5, and 6. Okay? This right here are all of your options that you can have, and as you can see, there are 3 even numbers. So that's 3 out of the 6 numbers. That is 1/2, 50%. So this is as likely as not. That's the probability that you're going to get an even number. Now this, what I've typed in here, is an example of what you call a sample space. A sample space is always written with the curly brackets, as you can see there. And what it is basically is it represents basically all the possible outcomes of an event. Okay, so if I roll a die, that means I can either get a die that lands on side 1, side 2, side 3, side 4, side 5, side 6. And so basically by writing out all of the different ways that this can happen, you are basically creating the sample space. And in actuality, let me fix this because sample spaces are separated with commas. But again, like I said, they do include the curly brackets, as you can see here. So that is practice with describing the probability. Now let's actually find what the probability is, okay? So the probability of an event happening is basically taking your total number of times an event occurs divided by the total number of equally possible likely, outcomes. Okay? And so basically, if you are trying to flip a coin and you want to find the probability of it landing on a head, well, the number of times that a head actually occurs is one time. Okay? The actual total number of equally likely possible outcomes is 2. It's either going to land on a head or a tail. Hence, you have a probability of 1/2. Now, do realize that's a very basic example, but that is what probability is. Let's take a look at this next example. Okay, let's get a little bit more. Let's advance these examples a little bit. Example 1 says, "What's the probability of landing on an even number on the spinner below?" So you take a spinner, you spin it, and the probability of landing on an even number. Well, let's take a look at our sample space. Okay. Our sample space, as you can see, are going to be the numbers 1, 2, 3, 4, 5, 6, 7, and 8. Okay? The event that we're looking at is the probability of landing on an even number. Well, those even numbers consist of 2, 4, 6, and 8. So as we can see, the probability of landing on an even number is the total number of outcomes of the event occurring, which is 4. There's 4 even numbers, out of the total number of possible outcomes, which is 8. 4 out of 8 does indeed reduce down to 1/2. Now, do realize this is the most broken down way to explain something like this, but it is pretty simple, okay? Let's look at the next one. It says, what's the probability of picking a heart from a standard deck of cards, which has 13 cards in each of the 4 suits: diamonds, clubs, hearts, and spades? Well, first off, let's talk about this. If you've never played cards before in your life, there are 4 different suits in a deck of cards: diamonds, clubs, hearts, and spades. There are 13 cards of each suit in each deck of cards. They are the ace card, the cards numbered 2, 3, 4, 5, 6, 7, 8, 9, and 10, the jack, the queen, and the king, consisting of 13 cards per each suit. So 13 cards per 4 suits equals a total of 52. There are 52 cards in each deck of cards. So because 52 cards exist in a deck of cards, again, we're not considering any hypotheticals, no jokers, no nothing like that. Our total possible outcomes is indeed 52. So that represents our denominator. And if we want the probability of picking a heart from a standard deck of cards, well, again, there are 13 cards of each suit. So 13 is our numerator, the number of times that we could potentially pick a heart from a deck of cards. So that becomes 13 out of 52, which does reduce down into 1/4. Please make sure that you do reduce your fractions. All right. Another way you could have looked at this is you could have seen that, okay, you have 4 suits. So 4 is your outcome. You want the probability of picking a heart. There's only 1 heart out of the 4 different suits that there are. So yes, 1 through 4. But the likelihood that you'll get this question again, very slim, very slim. What's the probability of rolling a number greater than a 4 on a standard number cube? Well, let's take a look. Again, our sample space are the numbers 1, 2, 3, 4, 5, and 6. We want to get a number that is greater than 4. Well, if we can look at the sample space, we see that those numbers are 5 and 6. So the probability of rolling a number greater than 4, we are not including 4 because it said greater than 4, not 4 and greater. So the probability of rolling a number that's greater than 4, well, there are 2 of those numbers that are greater than 4. I have a total possible 6 sides that we can get. So that does indeed reduce down to 1/3. And that's how you find probability. Now, the complement. The complement of an event is the set of all outcomes in a sample space that are not included in the event. That's what complement means. Everything that is not included in an event. An example of that would be, okay, in the event of rolling a 5 on a number cube, the complement would be rolling anything besides a 5, anything that's not a 5. So the complement will be rolling either a 1, a 2, a 3, a 4, or a 6. But no matter what, the probability of you rolling the 5 and the probability of you rolling something that's not a 5, no matter what, those two probabilities will always add up to be 1. The probability of the event happening and the probability of its complement is always equal to 1. So the probability of rolling a 5 plus the probability of not rolling a 5, no matter what, should always equal 1. So if you think about it, what's the probability of rolling a 5? That's going to be 1 out of 6. What's the probability of not rolling a 5? Well, that is 5 out of 6. There are 5 other sides. 1 6 plus 5 6. Whenever you're adding fractions, remember you only add the numerators. That is 6 6, which in the end does indeed equal 1. So no matter what, the complement and the original event should always add up to equal 1. Now again, these are very simple examples. A lot of times you can just figure out, okay, well, what's the opposite? What's the likelihood of this not happening? Instead of trying to go through this process of actually, seeing, okay, well, does it add up to equal 1? Whatever. But that is your standard formula. Let's take a look at some examples to finish up this foldable. What's the probability of not rolling a 2 on a standard number cube? Well, very similar to not rolling a 5, like the other example we had. And yes, that is 5 6. There's only one side that has this 2 on it. And so there are 5 other sides that don't have a 2. So the probability is 5 out of 6. There are 13 diamonds in a standard deck of 52 cards. If you pick one at random, and by one we mean one card at random. So if you pick one card from the 52 cards at random, what's the probability of not picking a diamond? Well, if there are 52 cards in a deck and there are 13 diamonds, you want to subtract those from each other. And so then that leaves you with 39 cards that are not diamonds. So then the probability of us not picking a diamond is going to be 39, the number of cards that are not a diamond, divided by 52, our total set. That does reduce down to be 3/4. Now, a spinner has 5 equal sections labeled A, B, C, D, and E. What's the probability of not landing on D? Well, there's 4 other sides that don't have a D labeled on it, so that's going to be 4 out of 5. And that's your basic probability. So far we've talked about how to find the probability of an event occurring and its complement. So now what we're going to do is we're going to look at the probability of combined events, or compound probability. I do apologize. Now, compound probability is basically the probability that consists of 2 or more simple events. And by simple, we mean things as like rolling a die, flipping a coin, spinning a spinner, reaching into a drawer and picking out a pair of a sock or something like that. If you want to look at complex events, that gets more into like conditional probability and other things, but right now we're just looking at the very basics. However, the probability of compound events is still the same. Okay, you're still looking at the probability of event happening, the number of favorable outcomes, i.e. the number of times the event occurs, over the total possible outcomes, the total number of times that, or the total possible things that you can get in this particular event. Okay, the total number of possible outcomes that you're looking at with compound probability are those from both events. Okay, now you're looking at 2 or more events: flipping a coin, rolling a die, flicking a spinner, and picking a marble out of a bag. Okay, so you're looking at the probability of both events. Okay, you can use tree diagrams to help you see it a little bit better if you need to, or you can use the fundamental counting principle, which is probably more likely of what we're going to be doing with the type of examples to calculate the probability of compound events. There is a shortcut to this. The shortcut is if you're looking at 2 events that have no effect on each other, no effect, flipping a coin and rolling a die. The outcome of one has no effect on the other. Basically what we can do is we can take the 2 different probabilities and multiply them together. So we can find the probability of compound events by basically multiplying the probability of each simple event. As you can see in this formula, the probability of A and B is equal to the probability of A times the probability of B. So the probability of rolling a 4 and flipping a head is basically equal to the probability of rolling a 4 times the probability of flipping a head. And all you do is you take those two probabilities and you multiply them together. So let's take a look. Look at the cards above that spell the word probability, okay? A card selected at random and a dime is tossed. We're looking for the probabilities of these two different things. As you can see, is written in the notation of P parentheses event. This time we have two events, two compound probabilities. And so what we're going to look at is we're going to look at the probability of picking up the letter B, and we're going to multiply by the probability of flipping a tails. How many B's are up there in the cards? Well, there are two B's. Out of how many? There are 11. So the probability of picking a B from the cards that spell probability is 2 out of 11. We're going to multiply that 2 over 11 by the probability of flipping a tail. Well, on a coin, there's two sides, and only one of those sides has a tail. So what do you do with those two probabilities? You multiply them. 2 11s times 1/2, and you multiply straight across when you're multiplying fractions. So that's going to be 2 over 22, which does reduce down to 1 over 11. And that's our probability. The probability of picking the B card and flipping a tail is going to be equal to 1 over 11. Let's take a look at the next one. Here we're looking at the probability of picking the R card, and we're going to find the probability of flipping a head. So because those are two independent events that have nothing to do with each other, we're going to multiply them together to find the probability of them equally happening at the same time. How many R cards are there? Well, there's only one. Out of how many cards? 11. So we're going to take that and we're going to multiply that by the probability of flipping a head. Well, there's only one head out of the two sides of that dime. So when we multiply straight across, it's going to give us 1 out of 22, and that is going to be the probability of picking the R card and flipping a head. Okay, that's how you find probability of compound events. Now, this should be a pretty simple concept. So what I want you guys to do is I want you guys to take some time and I want you to go through the rest of these examples and let's see if you guys are spot on with finding the probability of compound events. Remember, you find the probability of one, find the probability of the other, and you multiply them together to get your probability of those two events happening, or 3 events, depending on what the example is. Okay, let's see how you did. The probability of when you toss a dime and rolling a number cube, the probability of flipping a tail is 1/2. What you do is you multiply that by the probability of rolling a 1, which is 1/6. When you multiply those two probabilities together, you get 1/12. So that should have been an answer for the first one in number 2. Again, the probability of flipping a head is 1/2, and the probability of rolling an odd number is technically 3 out of 6, but we can reduce that down to 1 out of 2, and that's a total of 1/4. Here we are, we're still rolling a number cube, and do realize when a number cube is stated, it is assumed to be the 6-sided die. If it was going to be a 4-sided die or like a 20-sided die, then it would state as such. But a number cube, a standard number cube, is always 6 sides with the numbers 1 through 6 on it. So when a number cube just rolled and the spinner is spun, what's the probability of it being red? Well, there's only one red side out of the 6 sides, and there's only 1/6 out of the 6 sides on the die. So when you multiply that, that's going to give you 1 out of 36. Probability of spinning a green, that's still 1/6, times the probability of getting an even number, just like before, that is 1/2. So when you multiply them together, we get 1/12. And lastly, the probability of spinning a blue would be still 1/6. And the probability of getting a number greater than 2, well, if we think about that, that's the numbers 3, 4, 5, and 6. So that would be 4/6. 4/6 does reduce down to be 2/3. And so when we multiply those two probabilities together, we get 2 over 18, which does reduce to be 1/9. So those are our answers there. Now, I do realize, again, these are some very basic examples. We could go further. What if it asked you, what's the probability of spinning the spinner twice and getting orange both times? Okay, one spin has no effect on the other, so that's still independent events. So we'll look for the probability of getting orange the first time, and we're going to multiply that by the probability of getting orange the second time. Well, the probability of getting orange is 1/6, times the probability of getting orange again, which is 1/6, which is a total of 1/36. Okay, so combined events, compound probability. You just basically are taking the probability of the two events and multiplying them together. And again, you find probability by doing the number of times the event occurs over the total possible outcomes of that event. And that is probability.